Okay, example number 2. We have y equals x multiplied by x minus 6 to the power of a half. So you can see this one's a wee bit more complicated. So again, let u be the first term and let v be the second term. So u is equal to x and v is equal to x take away 6 to the power of a half. This one's easy. U dashed is equal to 1. This one here, a wee bit more complicated. So we're going to apply the chain rule here. So I bring the half to the front. I'll leave the x minus 6 as it is, and I subtract 1 from the power. Now a half take away 1 takes us down to minus a half. Okay, I would also times by the derivative of this, which is 1. But that's not really going to make a difference, so I'm just going to leave that. Okay. Right, if I then go to my product rule, which is dy by dx equal to u dot v dashed plus v dot u dashed, then my u is x times v dash, which is this complicated thing here. So x being multiplied by a half, x minus 6 to the minus a half. That's the u dot v dashed plus v dot u dashed. Now here's my v and here's my u dash. So I'm just going to actually write the one at the front. I'm going to put the u dashed at the front here. X minus 6 to the power of a half. Now you can work with your indices here, which are fractions, but I'm not really that keen on it. So I'm going to put this into root form and have it with a positive power first of all, and then with root form. So my x is going to stay on top of the fraction here. My 2 stays in the bottom, and x minus 6 to the minus a half is on the top. If I bring that down, it gives me x minus 6 to the positive a half, and anything to the power of a half is actually a square root. So I could write that as root x minus 6. Okay. Plus, and again, this just becomes x minus 6 to the half, which we could write in root form as root x minus 6. Okay. Now, we have differentiated it on this top line. We've tidied it up a wee bit. I think we could do a bit more manipulation, and obviously this one is a fraction and this is just a term on its own. If we take them over the same denominator to get a single fraction. Okay, so on the bottom here we've got 2 root x minus 6. So we also need that on the bottom here. So if I'm going to put over 2 root x minus 6 here, I would have to multiply the numerator by 2 root x minus 6. If you like, you could think of that as being over 1 just now. And it's like you're smiling a kiss. Okay, so we end up with x plus this 2 root x minus 6 times that root x minus 6, which is already there, all over 2 root x minus 6. Okay. If we multiply the root of something times the root of itself, then you just get that term itself. Okay, so we're left with x plus 2 bracket x minus 6 all over 2 root x minus 6, And what we can do is we can multiply out the numerator so that we can gather like terms. I'm just going to take this up here. Okay, I'll section that bit off. Okay, and move this bit up. All right. So I've got x plus 2x minus 12 over 2 root x minus 6, and that simplifies to 3x minus 12 over 2 root x minus 6. So you can see that the top line we could actually factorise here by taking out 3. And the reason that we would factorise that is in case the common factor that we take out would cancel with anything on the bottom, which it obviously doesn't in this case, but it's still good form if you can factorise that to do so, in case you can simplify it. Okay, so a wee bit more complicated. The hardest bit there, I would say, is the manipulation in between. So you want to be very comfortable with working with your indices, especially if they're fractions, or being able to jump easily between your fractional powers and root form. I personally prefer to work with root form, and then I use my rules of surds here. The root of something times the root of itself, or the same something again, just gives you the term without the square root symbol. Okay.